Welcome, everyone. My name is Anna. I work for Elastic. And today we're hosting our very first virtual Elastic London meetup. So thank you for joining us. We have Stathis here who will give a talk on using Elasticsearch as a time series database in the Endpoint Agent. After the talk, he will take questions in the Q&A app. So down in the Zoom bar, you can see Q&A. So post your question in there anytime. And then after the talk, we'll go through them and answer them. So yeah, now I will give it to Stathis.
Thank you, Anna. Just a second to share my screen. Yes. All right. Hi, everyone. Thank you for being here today. I hope everyone is staying safe. My name is Stathis, and I'm a senior software engineer for ThousandEyes. And today I'm going to be talking about Elasticsearch as a time series database in the Endpoint Agent. So, the agenda of today's talk. In the beginning, I'll say a few things about ThousandEyes and the Endpoint Agent to give you some context. Then I'll talk about the story of how we ended up using Elasticsearch for this part of the project. Then I'm going to talk about the backend architecture. Then I'm going to mention other use cases that we have for Elasticsearch in the ThousandEyes platform and in the Endpoint Agent specifically. And then I'll share some best practices, lessons learned, and future plans we have for Elasticsearch. So ThousandEyes offers a network intelligence platform where you can proactively monitor network performance of your critical business applications. And you can correlate that with the global internet health and ISP outages that might be ongoing or happened in the past. In a few words, we are the Google Maps for the internet. Now, the Endpoint Agent, which is the product I'm working on, I work at the backend team, is an application that runs on desktops and laptops on the endpoint users' machines. And with it, you can monitor your employees' network connectivity and the experience they're having from any network they have their laptop, for example, connected to. Especially these days that all of us are working remotely, this is a great tool that fills that gap. And we can also schedule several synthetic tests from the Endpoint Agent, which can run and collect all sorts of interesting network metrics or application level metrics, and also trace routes, and we can visualize them in our platform. But basically what the Endpoint Agent does, it submits a lot of data points to our backends, right? So when I joined ThousandEyes, that was probably a little bit over 3 years ago, one of my first tasks was to find the time series database. And in the Endpoint Agent product, we show a historical timeline, which we also need to apply a lot of filters on top of it. And then we need to bucket the data into bins. And then on top of that bin, we need to perform some kind of average on the metric that we want to plot. So my task was to find a time series database. The problem we had was that in our platform back then, we had MongoDB and MySQL as alternatives to use for a time series visualization. But first of all, MySQL was out of the question because we were already migrating away from it. And MongoDB, some colleagues of mine before I joined, they had tried performing and using the aggregations API and trying to plot time series with it, and it just wouldn't work. It would be very slow in the responses. And if you start adding more and more filters, it would just blow up. So it wasn't intended for a time series use case, at least for our data points. So I did my research, and I figured out that there were a lot of databases I could use, but basically, it came down to 3 for me back then, and I mainly evaluated them in terms of simplicity and ease of deployment. One of them was Prometheus. Probably all of us are aware with, or all of us probably use Prometheus. It's a time series database. It's mostly used for monitoring services and database metrics and all of that stuff. but it had no ability to do bulk imports, and especially you couldn't import historical data to it. And that's very important for the endpoint agent, because if the endpoint agent goes offline for a few hours, then when it comes back up, it needs to submit that data from 3 hours ago. So I needed this type of functionality, so Prometheus went out of the picture pretty early in the process. Then I started evaluating InfluxDB, and I also performed some benchmarks. It was targeted towards time series use cases, and it had a very nice SQL interface to talk to it. But replication was a paid feature. And at the time, I didn't have this flexibility. I needed an open source solution. So of course, and the purpose of these talks is with Elasticsearch, and the next contender was Elasticsearch, which I had previous experience with, but I've only used it for search, for the search use case. And yeah, Elasticsearch is open source and it scales horizontally, and you can find all sorts of documentation throughout the internet. So I gave it a go. So why would you consider Elasticsearch for time series? First of all, it's very easy to maintain, it scales horizontally. You can create all those complex reports with Kibana, for example. You can do offline analytics on top of your raw data. And the one cool thing that we found also in the process is that it can answer for you all types of questions that you may not think that it was possible before. But yeah, of course, it's not really targeted towards time series. You have to tune it a bit. And for example, in our use case, we disabled the _all field. That was in Elasticsearch 5, by the way, because in 7, this is not enabled by default. Or we could even save more space by not analyzing the string fields, because we didn't want to perform a full text search on the string fields. We only wanted to perform aggregations. So I knew that I was going to use Elasticsearch, but then I had to convince people. And the first thing I thought was performing like some kind of benchmark against Elasticsearch. By the way, at the time, I was like alone in this. I didn't have like a group of people supporting me in doing an Elasticsearch cluster. I had to figure out myself how to deploy stuff and how to benchmark. So what I did is I deployed an Elasticsearch cluster in Kubernetes by using some open source Kubernetes manifests I found in GitHub. And then I built this 4-data node cluster with 3 dedicated master nodes, because that was a very good recommendation. And I inserted around 65 million documents spread over 7 daily indices. Then my benchmark went like this. I queried half the data set. I queried the whole data set. And then I queried half the data set, and then I queried a specific document from the data set. And I had a custom Java application that I wrote that would perform around 20 requests per second and gather all those metrics. And I tracked all those averages, standard deviation, and percentiles into my report. The queries I performed were very simple. I used the date histogram aggregation and the terms aggregation. I used the terms aggregation because some of our data points that we receive they already tagged with a bin, so I don't need to use a date histogram in all our data points. And I also used Grafana to query Elasticsearch. Of course, I did it from my Java application, but I used also Grafana because it was easier for the rest of the company to see that I could query Elasticsearch and perform time series queries, and they were pretty fast. So this is part of the report that I compiled back then. That was on Elasticsearch 5. And I'm not going to go into too much detail, but the main theme of this benchmark was that most of the aggregations, they took less than a second most of the time. And that was mind-blowing at the time. Since we've been trying MongoDB, that was taking probably more than 5 seconds or even more. This was just out of this world. It was really powerful. The aggregations in Elasticsearch are really powerful. And of course, then I had to convince people further that this was a way to go. Elasticsearch was was a very good technology to use for our timeline. So what we did with a colleague is we did this. We shared the benchmark results in an internal tech talk, and we focused on the part that the Elasticsearch was very fast, and you could really use your raw data. You didn't need to pre-aggregate your data points in some kind of pre-specified bin. And more or less, that's we got the approval to test Elasticsearch in a real project. So the first project was an internal project, some internal dashboards for the Endpoint Agent. So these dashboards, we collect several interesting metrics for the Endpoint Agent, like how much time is it taking to talk to our backend, right? How much time is it taking to perform certain operations in the agent code? And this was built using Graphite, and we had the Grafana to visualize those Graphite metrics. So we replaced the Graphite backend with Elasticsearch. We did an Elasticsearch cluster on GCP. We deployed an Elasticsearch cluster on GCP, where we were pushing data to it through a Kafka topic. And from the Kafka topic, we had a Logstash instance that would consume all those data points and push them to Elasticsearch. And of course, from Grafana, we used the Elasticsearch plugin. We could have used the Kibana, but people back then were more familiar with Grafana instead of Kibana. So we replaced all those dashboards. This is how the Logstash configuration looked like. It's very simple. We just specified the Kafka input, where the servers are, the topics we want to consume from, the codec, the data type. And then on the output, we mapped the Elasticsearch instance that was running on GCP. So that was a very small project, and it was really easy to do. In a matter of weeks, we had replaced those dashboards. But now it was after that project, we proved a few things. But now it was time for the actual project, which was replacing the historical timeline with Elasticsearch queries. So the Endpoint Agent's timeline was one of the first timelines to have so many filters. And we had already started writing the aggregations using the MongoDB aggregations API. So we started replacing those queries with either date histogram or temps aggregations, and then we average on top of those buckets. And we used a lot of painless scripting because sometimes we don't want to average directly. We want to check if a field exists and do something about it. And the main advantages of using Elasticsearch, at least from the point of view of the Endpoint Agent, was that we could aggregate on top of the raw data. So, we instead of creating pre-aggregations of your data so that you can query them with MongoDB, for example, you don't need that with Elasticsearch. We just would specify the bin size, and Elasticsearch would just respond. And of course, you get analytics for free, which is really cool. For example, we have the product guy come to us and ask us, hey, which VPN types is Endpoint Agent deployed to? And we can just issue a query in our production Elasticsearch cluster and get that answer really fast, which was really interesting. So this is the architecture of our data pipeline. We run everything on Kubernetes, but our databases, we run them on proper VMs, not inside Kubernetes. On the left side, of course, we have the endpoint agents that submit all those metrics. And in the front line, we have some ingress services. They accept those data points. They will perform some basic validation. Then they will push them into Kafka. From Kafka, then we have a bunch of enrichers that will enrich those data points with relevant information that later we would like to query our data points on. For example, the location name, the coordinates, and things like that. Then we put for a second time into Kafka. And from there, we have a dumper service that will push data into MongoDB, which is we consider as a long-term storage. And we have another type of service, the Elasticsearch connectors, that push data to Elasticsearch and also manage our templates. And I'm going to talk about this in a bit. So technologies that we used for our pipeline, we rely heavily on Kafka for buffering all those events from the agents, and then we can consume them on our own pace behind the scenes. We use MongoDB again for our long-term storage, MySQL for metadata and customer data, but not data points. We use Elasticsearch, of course, for data points to perform all those timeline aggregations, but also populate our filters in the front ends in all the views. And we also rely on Redis for several cache concerns. Then, of course, it's almost everything is in Java. We use a lot of Spring Boot. We use a lot of Spring Kafka too. And to connect to Elasticsearch, we use the Zest client, which talks to the REST API. But we have plans to move to the official high-level REST client in the coming weeks. In terms of our indices, we use daily indices, of course. We keep around 31 days of data. We also have separate indices for our snapshot data. So snapshots is when a customer wants to, from his timeline, select a specific part and keep a snapshot that stays forever in the system, and he can share it, and they can share it with the public or internally. We manage our templates. Basically, we commit our Elasticsearch templates into Git, and then through the connector, we apply them when the service restarts, pretty similar to what Logstash does. And we use a curator to expire our indices and apply several aliases that we have. So this is our Elasticsearch 5 cluster. It's a 3-data node with 3 dedicated masters. We have an F5 load balancer in front, which load balances between the data nodes. We ingest around 500 data points per second, and this number is going to grow in the next few months. We expect it to grow by probably double. But 500 data points per second is at max, at peak time. It's not all the time. And then we store around 3.9 terabytes in total in our cluster. So regarding the Elasticsearch Sync connector, so basically all this application does is move data from Kafka to Elasticsearch safely. We tried Logstash in the past for this piece of software instead of building our own, but because we have a custom serialization format, I wasn't able to make Logstash work in that case. And I'm more of a JVM guy, Java guy, so I prefer to use Java tools and build my own things. So yeah, I built this project, the Endpoint Kafka connectors. My main motivation is that I shared a lot of the Kafka code I had already used for building all those services from the pipeline before. And I could also reuse our ThousandEyes platform infrastructure to deploy, monitor, and alert on that service. And again, of course, this was built using Spring Boot and Spring Kafka and Zest client. The cool thing about the connectors, though, is that they are configurable through an SQL-like language. So here I show you one part of the configuration where you specify the consumer group from Kafka that you want to consume from. And then through the SQL language, you specify how you want to consume that data and where do you want to put them. So you can insert into a target index. With select, you can select your fields that you are interested from that payload. From the source topic you want to consume from, and then PKID stands for primary key ID, which means that the connector will push to Elasticsearch data points with ID, the ID of the payload. And as I mentioned earlier, we also manage the templates through that service. So you have to also specify where your template file is. So regarding our read services, so those that serve the timeline, we mainly do perform those aggregations I mentioned before. And we also populate our filters, so distinct values. And we don't really use scoring capabilities. And we might remove the scoring capabilities in the future to maybe improve some of our queries, but we haven't tested that yet. We have some cases where we might retrieve the raw objects from Elasticsearch instead of just performing aggregations. But mainly we avoid doing those types of aggregations in MongoDB. So we might, for example, use MongoDB for the round details, but for those historical timeline aggregations, we never use MongoDB. Now, another project that we built, which is also related to time series, was the overview page for the Endpoint Agent. Now, this page tries to surface the experience of your endpoint agents for the last day, and it consists of 5 different parts, like a general aggregation, which is on top, then an aggregation based on visited site, an aggregation based on location, and then two top 5s of the synthetic tests sorted by their main metric. For example, for the HTTP tests, it's the average availability. For the network test, it's the average packet loss. But for those tests, we need also to display the timeline in the view. So the cool thing about this page is that in the beginning, I wasn't sure if Elasticsearch would work for it. But we already had the data there, so I gave it a go. And I was amazed that this complex aggregation, which consists of many aggregations and many parts, Elasticsearch was the right tool for it. And we use Micronaut, and we front the service with GraphQL. So every piece of the page is a GraphQL resolver, for example, that talks to Elasticsearch. And the cool thing is I was able to ship this backend in a matter of 2 weeks because I had everything in Elasticsearch. Because in the beginning I was afraid I was going to build some kind of pre-aggregations and stuff like that, but it's not. It's great that this just worked. And yeah, this is how the synthetic test aggregation looks like. So this is pretty cool, and it's the power of the language amazes me, because basically you have to, for a specific period, you have to do an average of a specific metric from your data set, but then you want Elasticsearch to also return you all the data points grouped by their round ID. And this is expressed in one query. It's just amazing. It's just really cool. But of course now, because the endpoint agent is getting more and more traction these days, we decided that it's time to move to a new cluster. As you recall, we were in an Elasticsearch 5 cluster. So we decided to move to an Elasticsearch 7 cluster, a brand new Elasticsearch 7 cluster in AWS, managed by us. So our new cluster has 6 data nodes, 3 dedicated master nodes. It uses an AWS network load balancer in front of the data nodes, and it has automated snapshots to S3. So our strategy to migrate from Elasticsearch 5 to 7 was the following. First, we would migrate the right applications. As you recall, we have most of our data points in Kafka, and we keep 3 days of data points in Kafka. So what we did is we spin up new Elasticsearch connectors that will consume from a different consumer group, and they would push to the Elasticsearch 7 cluster. So now you had the cluster that had 3 days worth of data, and as you kept going, it synced with the newer data that were coming in from the agents. And then we used the index API to index all the data points from the old cluster. And it was really easy to do. We just had to whitelist the old cluster in the new cluster through a setting, then add the certificates to talk to the old cluster from the new, and then we just used the index API. This process took around 3 days for our data points, and this is how it looks like in terms of megabytes per second through the network. I didn't submit all their index tasks at once. I split them into 3 parts, and That went really well. And now the two clusters, they had the same data, and through Kafka, they would keep syncing with each other. So now we had to also migrate the read applications. And to do that, we basically pointed our integration tests to an Elasticsearch 7 Docker instance, and we fixed the queries. We didn't face a lot of problems, to be honest, in terms of the queries. And then when we finished with fixing those queries, we deployed those services in an isolated environment. We performed some canary tests, make sure we queried all of the data points from across all accounts and across all snapshots. And then when we were confident, we just switched the traffic to the new services that were pointing to the new Elasticsearch cluster. In terms of code changes, the main things that changed was that the document types are deprecated in Elasticsearch 7, and they're going to be moved in Elasticsearch 8. That was very easy to do because Elasticsearch has done a good job in telling that to the developers a long time ago. So we already knew from Elasticsearch 5 days that this was going to be deprecated at some point in the future. So we only had per index one type inside the index. So it was a very easy transition for us. The index template format changed a bit, but there was very few minor changes. Our main issue was with painless. We were using this annotation, the doc field.value, in several places, but this will throw an exception if the document is missing a value for that field. And basically, you have to first check if the field is there. And that we didn't catch that from the integration tests, because in the integration tests, the fields were always there. But in production, some fields were not there. Well, of course, we got that through the canary testing. Another thing that changed was the max buckets property. So the amount of buckets that are returned in an aggregation, which was in Elasticsearch 7 was set to 10,000. But because we support tests that have 1 minute interval, and we keep that for 31 days, and we won't query all of it, we need to create a little bit over 45K buckets. Another thing that broke for us was hits.total now is an object in the response instead of a value. We used to check that just to make sure that documents are returned from Elasticsearch, and that broke for us, but that was an easy fix. So improvements that we saw in the new cluster, first of all, the size of the indices was smaller. I think that can be attributed to that by default, there's no, the Elasticsearch 7 doesn't index the _all field, where all the fields of the document are indexed in one field for wide searches. Of course, we saw a better throughput for the cluster. We had the services writing to the old cluster and the new cluster, and then when we switched to the new one, we weren't seeing any consumer lag from Kafka. Compared to before, we were seeing some consumer lag. And now in the new cluster, another improvement that we really liked is the file-based realm for managing users. Now we didn't need to restart the cluster to add the user, which was really cool. So we use Elasticsearch also in other parts of the product, and one of them, of course, is for logs. We collect all our logs from our databases, services, etc., and we query them through Kibana. And of course, we recently introduced the Elastic APM, which is an amazing product. We use it all the time to discover bottlenecks in our code. Here, for example, I have a piece of code we had where it was querying Elasticsearch 8 times. And I optimized that to do one multi-search query instead. So yeah, we really like the Elastic APM product. It's really cool. So I guess some best practices now and lessons learned from all this experience. First of all, if you can, always use cluster per product. So in ThousandEyes, we have several sub-products, and we didn't want, when one part of the product is facing some kind of availability issues, to impact the rest of the platform. So we're really happy that we did that early on. We don't manage index templates by hand, so have them somewhere committed in Git and have a process to apply it to your cluster. Be careful in your aggregation queries to filter before to be able to improve those queries. And a very interesting one was if you're using the Apache HTTP client through Zest, for example, from Zest REST client for Elasticsearch, make sure that you evict idle connections, or else you will start getting 500s when you perform rolling restart on the cluster because of connection resets. So evicting idle connections is a very good strategy for that, to avoid having that. So regarding the future of the project, because we are expecting to grow and even double in the next months. Now that we move to AWS, we will just probably add more Elasticsearch nodes as we go. We would like also to evaluate the usage using routing to improve some of our queries by collocating data, for example. And because we like a lot working with events in the backend, and specifically events from databases, we are kind of excited for the changes API that's coming in the next Elasticsearch version at some point, not sure when. So we're excited about that feature. I guess I will leave you with this screenshot. This is our disk usage in the last 90 days. As you can see in the beginning, we were around 33%. Now we are at around 80%. Luckily, we have already migrated away from that cluster, and we will be commissioning it out in the next few weeks. But yeah, it's a great journey so far. And yeah, with that, time for questions.
Yeah, thank you, Stathis. That was a great talk. I really enjoyed it. So thank you. If you have any questions, please drop them in the Q&A app, and I will read them out and we'll go through them. John has a question. What are the downsides that you found by using Elasticsearch?
Downsides. That was the thing is that we try to use the best tool per case. So because now we have the data points in both databases, MongoDB and Elasticsearch. If something is better suited for MongoDB, we'll do it in MongoDB. If something is done better by Elasticsearch, we'll do it in Elasticsearch. So I never really had some kind of something like that up to now, because I have this flexibility to use other types of database. I think that's why. I don't know if this answers the question, but.
Okay. Do we have any other questions? I have a question. Actually, my colleague asked me privately in our Slack, why did you choose AWS and not Elastic Cloud?
We want to manage our own infrastructure. I guess that's the main thing.
Okay.
That's all. That's all.
Okay.
We want that flexibility. That's all.
Any other questions? No? Okay. If you think of any other questions, you can find set to this information on the screen. Also, I will be editing this video and I will upload it to our YouTube channel. Actually, one more question. Alejandro, who works for Elastic, is asking, do you have an example when you prefer MongoDB over Elasticsearch? What are the kind of use cases for that?
That's a very good question. Yeah, not entirely sure right now. Is there any? Yeah, don't have something in mind, to be honest, to say.
That's
Yeah, but
okay.
yeah, sorry. Yeah.
Okay. All right. Any other questions? If not, I was going to say I will edit this video and we will upload it to the YouTube channel tomorrow. There's another question. Is yes Jest causing any performance issues at the moment?
Not really, but we have plans to migrate to the high-level official client, to the REST high-level official client soon.
Okay. Awesome. If any of you are interested in presenting as well, please reach out to us. We're always looking for presenters. One more question. For querying Elasticsearch, do you consider using maybe reactive driver with Spring, for example, or is that not applicable?
Reactive driver. Yeah, I considered it. Of course, it is applicable. In the overview service I talked about earlier, I used the async client and I use also completable futures. Of course, someone will say this is not reactive, of course, but yeah, if you try to build with the reactive client, I guess you have to build also the responses and the requests from scratch. So unless you can find a library for that, but yeah, I considered it in the past, but I ended up using the async client for that.
Okay. Any more questions? All right. Cool. So thank you again for your time. If you want to speak at the next meetup, let us know. A video will be provided tomorrow. And I hope to see you at a future meetup in person or virtually soon. Stay safe, enjoy the nice weather if you're in London, and have a nice evening. Bye, everyone. And
Right.
thank you again, Stathis.